So as promised, I was going to do a couple more examples related to my lesson video where we have to find values of trig functions given an equation on the terminal side. So these are a few more examples. So here's the situation. So an equation theta of the terminal side is given. Sketch the situation and then find the 6 trig function values. So I'm going to do this 3 times with these 3 different situations. Okay, so let's just jump right into it. So negative 6x minus y equals 0, and x is greater than or equal to 0. So very similar process to what I was talking about in the lesson video, but I'll build the whole thing back up. So I recommend, I personally just like to solve for y first. So if I solve for y, so I bring the 6x over to the other side, I get y equals negative 6x. And so then I can say that this equation here, this will turn into this. And so then what I'm going to do is I'm going to graph this situation where x is greater than or equal to 0. I'm going to graph it here. So I start here at the origin. I'm supposed to start at 0, and then I go where the x's are greater than 0. So everything over here is greater than or equal to 0. So I have just plotted like an extra point here, because I used the slope of this line. So this is how I approached this situation. Okay, so remember, this is the terminal side. And so the way that this works, you have your initial side always starts here, and then you've got your theta that goes like this. And when you're first learning about trig functions, you just like kind of want to be mindful of this, okay? I know that we just like threw these at you, and what you're doing is you're developing an intuition of like certain measures of theta and how that translates to the value of the function. Okay, now remember, and I talked about this in the other video too, since no point was given, so in some examples you're given a point and you can like kind of create a kind of a right triangle that you can use to build the values of your trig functions. But in this case, there was no point given, so I just choose an easy point. And I find that the easiest point is the one that I was using with the slope. So in this case, I started here at 0, 0. I counted down 6 over 1. So this is my situation here. Okay, so that is going to be what I use then to kind of create this right triangle situation, and then I can start kind of, building up some values. So my x in this case is going to be 1, my y in this case is going to be negative 6. So you always want to reflect kind of the negativeness of that point in your sides, because that's important when you're building these ratios with these trig functions. Okay, so the last thing I have to do is I have to figure out what r is. So I use these two sides to figure that out. So I'm going to take 1 squared plus negative 6 squared, and then I just, go through the motions. So square root of 1 plus 36, and then that's square root of 37, bada bing, bada boom. So I've got, this is my r squared root of 37, and sorry, I kind of jumped the gun here. I threw all the functions up. But this is where we're going, right? So this is what I want to do next, is I want to fill in just all these functions. And so let's do it. Let's start, putting our ratios together. So for sine of theta, I've got y over r. So this is going to come to, negative 6 over the square root of 37. So negative 6 over the square root of 37. And then, like I said, I have to rationalize that. So I get negative 6 times the square root of 37 over 37. And then as I move on to cosine, so I've got 1 over the square root of 37. And then I just want to rationalize that again. So I get square root of 37 over 37. Tangent, so tangent is y over x. This will be negative 6 over 1, so this will just be negative 6. And then the rest, as we just continue on with that. So I've got the square root of 37 over negative 6. I've got the square root of 37 over 1, and then negative 1 over 6. And you will note that these are all reciprocals of one another, and we'll make a bigger deal about that later on. Okay, so moving on to example B. So we're going to do the same thing. So I'm going to take this equation here. First, I want to just rewrite it so that I have it just in slope-intercept form, just so it's a little easier to graph. And then I can go ahead and graph it. So remember, my x's have to be greater than or equal to 0. So I really blew up this graph. This is 1 and this is 1, so I just went down 1 and over 1. And then remember, we talked about with these problems, so you can choose whatever problem you want, or whatever point you want, as long as it is on the terminal side. So we'll just go ahead and use this point here to kind of build up our triangle. So I can go ahead and work through this. So my x side is 1, my y is negative 1, and then I've just got to figure out what my r is. So my r, I'll take 1 squared plus negative 1 squared. So that comes out to r is the square root of 2, and so I can fill that in. And then once again, I can go through and I can just work through all these different ratios. So you might want to just pause the video here and work through these yourself, and then hit play when you think you've got them all. So I'm just going to go through these. So taking y over r, so that'll be negative 1 over the square root of 2, so negative 1 over the square root of 2, cosine x over r, oops, sorry, and I forgot this. So rationalize 2, right? So this becomes negative square root of 2 over 2, my bad. And then continuing on here, so x over r, this is 1 over the square root of 2, so once again rationalize with tangent of theta, so I've got negative 1 over 1, so this will just equal negative 1. And then the rest are all listed here. So again, it's just kind of following along and creating, you know, the necessary ratios. Okay, so the last one that I want to talk about is one that feels a little bit different from the previous two examples. So I've got x equals 0 and y is greater than or equal to 0. So I start with my graph here, and I'm actually going to just plot this in green so you can see it. So it starts here and moves up. Okay, so this is a very different problem, and I want to make sure that you kind of get this. So remember, my terminal side starts over here, right? So I'm opening from here to here. So I just want to point out that this is a 90-degree angle, right? Like if I just look at it, you can tell it's a 90-degree angle. And there's kind of an inherent issue with this. There's no clear point to work with, like we had with the previous examples where it's like, oh, I'll just select that point that I was using as I was kind of plotting out my slope. So remember, the idea though is that if you can just choose a point that is on your terminal side. So I need to just choose a point on my terminal side, and don't make it anything crazy, just 0, 1. We're always going to end up choosing that point. It's just so much easier to work with, and you'll get the same kind of ratio anyways. So the other thing I want to note here, there's no right triangle that's formed from this point here, but we're still going to use this side. Okay, so I think this is a little subtle, so I want to make sure you understand like why this is different, because I think it's very easy to miss. So let me just draw one more terminal side. Let's pretend for a second that I had this pink side. Let's pretend this was my terminal side, and let's say I choose, I don't know, like this point right here, and I'm working on making that right triangle. So remember, what you usually do with that, you select that point, and then you draw straight down to the x-axis. So do you see how this is a little bit different? If I draw straight down from this point, it doesn't create a right triangle. And you might say, well, why can't you just connect from here to here? So you can't do that because it's not using the same logic. Does that make sense? So we don't want to deviate from the logic that we've used for all these other triangle cases. So what's going to end up happening, we still use this side, and we're actually going to pretend like it's a right triangle that's kind of messed up with a width of 0. So I'm going to show you what I mean in a moment. Okay, so this side here, so from here to here, we're going to say that the height of this, pretend for a second it's a right triangle, the height is 1, right? That comes from the point that we selected. And then still using that point that we selected, we're just going to say like the other leg of this triangle is like, think of it as 0. I'm literally using this point here like I have in all my previous examples. So I'm just continuing on with the logic really. And so remember, after you get your x and your y, you come up with r. So if I want to come up with r, I've got my x squared and my y squared, and I take the square root. So I get it. This looks super odd, but we're going to go with it, okay? And we get that our r is equal to 1. So I'm just going to note that over here. My r in this case is equal to 1. So look, I know this is weird, but this totally works. And this is the way that you do want to think about these problems. So when you can't create, let's just go back for a second. When you can't create like this clear right triangle picture, like if you can't draw straight down from the point, then this approach that we were just talking about, this is totally what you want to do. So it might feel strange at first, but you probably just learned this, so you'll get used to this line of thinking. Okay, so anyways, it's still the same functions. So now that I've got all this stuff, it still works the same. So I've got sine of theta equals y over r, so that's going to be 1 over 1, right? 1 over 1, and that's just going to equal 1. And then for cosine of theta, so that's going to be 0 over 1, so that's just going to equal 0 in this case. And then tangent of theta, so here's something interesting.
It's y over x. So that's going to be 1 over 0. 1 over 0, if you divide by 0, that's undefined. So that's just what it is. And then cosecant of theta is going to come out to 1 over 1, which is still 1. And then secant of theta, so now I'm going to have r over x. This is going to be 1 over 0. So once again, that's undefined. And then you have cotangent of theta, so that's 0 over 1, so that equals 0. So kind of a strange example, but this is totally the right way to think about it. You just kind of have to get used to it. And otherwise, that's all I've got in this video, guys. So I'll catch you later.